Okay, we're going to be talking about calculating probabilities of events using two-way tables. Now, I've already done a lot of the work here. Let me scroll up so y'all can read that. I'm going to give you a second to pause the video and read the question or the information. Okay, so as you can see, I've already wrote in a lot of numbers, and I'm going to try and explain those to you right quick. The 18 to 25-year-old row, the total of them, whoops, didn't want to do that, is 75. So if I add up all the 18 to 25-year-olds, there was 75 that voted. And so that's what those are on the right side. Now on the bottom here, this is the total of that column, the yes male column, there was 119. And if you add up the totals, they should both equal 515. Now, these at the top is just the total yes, the total no, and the total no answers. The numbers in the middle are just the total 18 to 25-year-old yeses. And so like this 53 down here would be the total no's for the 66 and older row. Okay. So hopefully that explains to you a little bit about what's going on there. Now, number one, based on this survey, do you think the school board should recommend building a new high school? Explain your answer. Well, if we look at the total yeses, which was 273 out of 515, that's about a little over 50%. So let's look at it. It's 273 divided by 515. That's about 53%. So a little over half says yes, they should. So yeah, they should vote to build the new building. Now that's a little close, 53%. You may want to have another vote, kind of like almost like a tiebreaker, just to see if more people will come out and vote. But just based on the information that we have now, that's what we could say. Now, I actually cut off number 2, so I'm going to write it up here. And just listen to me. It says that if we take a 21-year-old, do you think he would indicate that the town should build a high school? Why or why not? So what we would do here is we would say there was 61 yeses in the 18 to 25-year-old. So the 21-year column or row. There was 61 yeses out of 75. So just based on that, which is about 81%, we would say then yes, they are probably going to be a yes answer for the 21-year-old male. Okay. You can also look at that, maybe say that, there's only 14 no's and there's 61 yeses. So you can kind of look and just see right off the bat that there's probably going to be a yes answer. Okay, page 2. Once again, I just copied that chart over here so we can continue to look at it, but it says a 55-year-old, do you think she would indicate that the town would build a high school? Why or why not? Well, a 55-year-old would be in the 41 to 65 row, and the most is 79, so that's a no, and that column is a total of 79. So we look at the 79 no's, and that would be out of 149, and that would be about, it's going to be a little over half. So it's a little bit over halfway. I can find out exactly. It's about 53%. Now remember, these are no's. I looked at this number here, the 79, which is in the no column. So no, they would not recommend it. because the majority of them said no. Now, the school board wondered if number 4, the probability of recommending a new high school was different because of the age different categories. Okay. So why would you think that these people classified them by age groups? And that's what it's saying, and especially specifically these. Okay. Well, if we just think about it, and this is the part about statistics that you're going to have to start probably getting into that you're not really used to doing. Y'all can look at numbers and get probability, percentages, that type of stuff. But we want to make sense of the data. Well, if we look at the 18 to 21 year olds, those people are just right out of high school, right? Now, there was a good bit of, there were 75 of those, which was not near as many as there was in the 26 to 40 range. Now, why would there be more in the 26 to 40? Well, the reason why is probably because these people probably will have the school-age children. So they're going to be a little bit more vocal as to whether they're going to get a new high school or not. Okay, which probably means they're going to be paying the taxes to build the school building, and is that going to be worth it for their kids to have a new high school? Okay, so that's probably the reason why those have the majority. And that also can go into the 41 to 65 year olds as well. Now, why is it not as high in the 66 and older? Well, probably if we think about it, their kids that they've had are probably in their 40s now. And so they may have grandchildren, but they're also probably going to have a lot of their kids that's moved out of the town, that's moved away. So they really don't care whether they get a high school or not. And 2, there may not be as many older people there. Okay, so there's a lot of different ways you can look at it. We don't know, but we need to think about all these things whenever we're trying to make a logical, a reasonable explanation about this data. Now, if we go to page 3, once again, don't worry about the writing on the right there, but that's in the category or in those yes, no, no answer. That's all from the previous chart that I had already written it all in, because I just know that the more data, the more numbers I have, the better it is, the easier it is to look at these answers. And so here they just wanted you to put into a chart or a table that did not have the male and female categories. So they don't care about the gender. They just want to look at the yes, no's, and the age groups. So there that is filled in. Now, we need to look at number 6. And this is how really what you need to be thinking about whenever you hear statistics and you hear probabilities that are thrown out in the news, whether it be online, at a website, or the live news broadcast. You need to think, how are they manipulating those statistics or those probabilities? So let's look. It says a local news service plans to write an article summarizing the survey results. 3 possible headlines of this article are provided below. Is each headline accurate or inaccurate? Support your answer using probabilities calculated using the table above. Okay. So it says Waldo voters likely to support building a new high school. Well, if we just look at the yeses and the nos, there's 273 yeses to 230 nos. Well, they are more likely, that is an accurate statement, they would be more likely to build the school because it's 273 out of 515. Okay? And we really don't care about the no votes. We really just need the yes and the no's. Okay? So yeah, we can look at that and say that is an accurate headline. Headline number 2, older voters less likely to support building a new high school. Now notice it doesn't say less likely to vote, but it says less likely to support, so to say yes, okay? So if we look at the older voters, and you can classify that as these two categories, well, both of them, we have 79 no's to 66 yeses, and we have 53 no's to 33 yeses. So that is a true statement as well, because there's more no votes in those older categories than they are yes votes. So they are less likely to support. All right, headline number 3. Young voters not interested in building a new high school. I don't think we can say that. I mean, there's 61 of them to 14 no's. So that is not an accurate statement. Okay. Now, I think the reason why they might have thrown this headline in there is because there's only 75 people that voted. Now, younger vote is not interested, or it could have also been we have 0 no answers, which would completely contradict that because they are voting there. So I really don't know where they get that headline from, other than maybe it would be the 75. That's low. That's the lowest of all the categories. But that's the reason why you need to be thinking about, are these correct statements? All right. Page 4. So it says, I'm gonna let you pause the video and read this. Okay. Now, if you look at it, it wants to know if there's only 25 voters, and then in this category, 110 in this category, 130 in the 45 to 61 category, and then the 80 in the 60 and older. So the reason why I went ahead and wrote this is if you go back and look at your chart here, this is this one. So that 18 to 25, this is the 26 to 40, this is the 41 to 65, and these are the older ones. I've already calculated your yes votes, which is what you need. And you need that percentage there, that on the right. Okay, 61 out of 75 for those. There's your percentages. So let me go over here and write, this would be times point 0.813, and then this percentage of yes votes for this category was, and I'll explain to you why I'm multiplying it by the 130 here, or beside these numbers in just a second. Since we're making a prediction, we're only going to base the number of voters that come out, which is 25, 110, 130, and 80. We're going to base that on the probability of a yes vote. Okay, that category had approximately an 81% yes vote, or a 0.813 chance of voting yes. So we're just going to multiply that by the number of voters that come out, which was 25. Same thing for the next category. 110 voters are going to come out. The yes vote for them is approximately 56%. Next category, 41 to 65s, there's 130 that's going to come out and vote. They're approximately going to vote yes 44% of the time. And same thing for the last category there. Well, when we do that, we just add all that up. And when you do that, you're going to get 169 yes votes. Because remember, this is the number of voters. This is the likelihood of yes votes. And so we're going to have 169 yes votes. But we also need to see add these up and see out of how many votes. And if you add those up, you get 345 votes. So if you calculate that, 169 divided by 345, that is about, it's right at 49%. But remember, this is yes votes. So there's going to be more no votes. So we would say that they would vote no. Now it's really close, but they're probably going to vote no. Now, number 8 says, is it possible that your prediction of the election outcome might be incorrect? Yes, because these are only predictions. Because what if all 25 voters that come out are going to vote no? We don't know that. They may be really adamant about them voting no, so they all come out and vote no. Or they could have all come out and voted yes, which would have been 25 yes votes instead of this accounts for about 20 yes votes if you add those up, or if you multiply those together. But they could have all come out and voted yes. So we really don't know. Predictions are based, this prediction is based on the outcome of the voters. We're just guessing about the outcome of the voters. Okay. 5, I'll give you a chance to pause the recording and watch that video right quick. Pause it and read that question. Okay. So, I really like hypothetical 1000 tables. It's kind of like a puzzle to me to figure it out, because if they're going to give you a couple of probabilities to fill in the table, you have to figure out the rest. Okay, so that's what I like doing. I like doing that type of stuff. Now, if you go over here to this next table, or this next chart, let me go ahead and I need to, do a screenshot here, and I'll just move this over so we don't have to continue flipping back and forth. And actually, I thought I already had it on here, so sorry about that. I'll put it here, make it a little smaller. Okay, so now it says the probability that the randomly selected student at the high school has asthma is 0.193. So what you're looking at here is the student that has asthma. So if we look at the total, we don't care if they have a household smoker or not. So that's going to go in cell 3, because that's just talking about the total. And it's going to be 193 students. Well, how do I get 193 students? Because I'm hypothetically saying that this is out of a total of 1,000 students. Well, 0.193, right? That's 193 thousandths times 1,000. We'll just move the decimal place, right? 1, 2, 3, and that gives us our 193 students. Now, number 10 says the probability that a randomly selected student has at least one household member who smokes. So if we're looking at household members that smoke, we don't care if the student has asthma. We don't care if he doesn't have asthma. So we're just looking at cell 8 right here. And since it's 421 thousandths, that means there would be 421 students. Remember, this is just a hypothetical 1,000. We're just trying to actually get some numbers here of students. 11 says, in additional to the previous given possibilities, the possibility that a randomly selected student has at least one household member who smokes, so one household member who smokes and has asthma. So a household that smokes and has asthmas, that would be cell 2. And they're going to be 120, hypothetically. All right? That's how you would fill out. Now, you tell me, if we have, oh wait, I didn't write the cell for the first one. Cell 3, I think it was. Yeah, cell 3. If we have cell 2 and cell 3, we could figure out cell 1. We already have this, so if we have cell 3, and I guess that would be considered cell 9, we could figure out cell 6. Since we have 2 and 8, we can figure out cell 5. Well, now that we have cell 8 and cell 9, we could figure out cell 7, and so forth. So now we're just going to figure out the rest of the students based on the information we've already been given. Okay? So now then, if we do that, here are your numbers. Okay? And the way we did that, we said 1,000, which is cell 9, minus cell 3, which is 193, and we got that number to be 807 for cell 6. Okay, so we're just going through and subtracting and figuring out, if we got the total, we're going to subtract the other one. Or if we have cell 1 and cell 2, or cell 4 and cell 5, we're just going to add them up and get cell 6. And that's how you would do that. So hopefully you're able to figure those out, but there they are for you. And the reason why I gave them for you, because we're going to have to use those here. Okay, so based on the completed two-way table, estimate the following possibilities as a fraction and also as a decimal, round to the nearest, or round to the 3 decimal places. Okay, so a random student that has asthma would probably, what is the probability that he has at least one household member who smokes? So first you're going to look at, this is going to be your denominator on your fraction. That's the whole. We're looking at number of students that have asthma. Well, that's 193 according to our chart. Okay, student has asthma, the total 193. But it wants to know the probability that they have one household member who smokes. Well, at least one household member in this range right here would be 120. And the probability is going to be about 0.622. Okay? Now, B. Randomly selected student does not have asthma. So now we're looking at 807 as our whole number, or as our denominator. What is the probability that they have at least one? So that would be here, and that's going to be 301. And that's approximately, if we divide that, you would get 0.373. Now, randomly selected student has at least one household member who smokes. What is the probability this student has asthma? So we're looking first at the ones that have a household that smoke, one person at least. That would be your total. Well, that's 421. Now, what's the probability that the student has asthma? Well, that is the column there, or the row there with 120, which makes that out to be about 285, I think. Okay, so there's how you calculate those. You just divide. Whenever you're finding probabilities, you just divide the quantity over the whole, and that gives you your probability. Quantity over whole equals probability. Okay? Now, do you think, number 14, whether or not a student has asthma is related to whether or not they have at least one family member who smokes? Well, if you look at, let me try and erase this. Okay? If you look at this chart, the column with students that has asthma and the students that do not have asthma, look at which way should be reversed. 120 to, you would have 120 to 73 that do not have a household member and has asthma. And then students that don't have asthma, they have a very less number of the ones in the house. Okay? So yeah, if you look at both of those, yes, it is a factor. Okay? Definitely a factor. It is related. Okay? And that's probably true. As a child, I had athletic-induced asthma, and my dad smoked with me in the car and in the house some. Actually, my mom made him start smoking outside when I was young and was diagnosed. But yeah, I think smoking has definitely an effect on the children. All right, I think that's it. Just go to the lesson summary. Data organized in a two-way frequency table can be used to calculate probabilities. In certain problems, probabilities that are known can be used to create a hypothetical 1,000 two-way table. The hypothetical population of 1,000 can then be used to calculate probabilities. Probabilities are always interpreted in the context. So this lesson is going to have a lot of different parts. I mean, it's probably going to have, if you look at it, it probably has 50-something questions. But know that probably one of those or 10 of those questions are simply just filling in those numbers on the chart. So it's not going to be that much. But if you have questions, ask.